All right. Another theory time. Time to explain something more logical. Two things today. So first off, man-made gravity. What is gravity, you ask? This is you, a simple-minded fellow, right? You are on Earth, our beautiful blue planet, blue and green. And gravity is the force that keeps you down. Oh yeah, we need it, or else we'd be flying away. So now my theory. So of course, as some may know, while in space, you just float. Because there is zero gravity. Now we have that across, the base definition of gravity. The problem with space is there not being gravity. Gravity, without gravity, causes muscle dilation, oh my bell's on properly, various other problems. So, what we do to solve that? You know those teacup rides? Let's draw a little diagram. 1 second. Little teacup rides, right? What do? They spin. Okay? They spin around. And you've always got that, on the inside of it. I'll just leave that there. They've got, so this is going to be a bird's eye view. They've got this thing right here. This, we're going to name the spinner. Right? This thing right here, you can have people on the outside who are like me and just spin that. Because it's really fun, because while this is spinning, everything else is also spinning. Right? So you get very dizzy and it's very fun. And when you're spinning, you're kind of pushed along the wall of the cup. Here, you're kind of like stuck, like all the gravity pushing you against the wall from its spinning. There's also, I call it my teacup theory, that's why I use teacups as an example. There's also that other ride, that this Gravitron or something, where everyone kind of stands along, they're all along the outside, while it kind of it's like a big circular thing while it spins. And the people are stuck on the wall because of the gravity of that. Right? So, what we do, right, is as you can see my Christmas card there. So, while they're in space, we have this thing. It's this ball, right? We're going to make it look fancy. If it's going into space, it's got to look nice and styling, and as the kids would say, blessing. So right here you've got this ball. The ball could theoretically be one of the special ones where it rotates like that. Like it can kind of rotate in every way. And then it could kind of pull them to the outside, kind of. Or maybe even if it rotated consistently, like called the gyro or gyro, whatever you want to call it, is just, it can rotate any direction, like, ball. Like, it can go down like that and over like that. That's a good drawing. But basically, it can do that. Theoretically, if that could spin, it might let them kind of maintain gravity within that sphere. That's just a small idea. Secondly, wait. Oh, that didn't work. 1 second. One more. There you go. So there's muscle dilation, right? So the way we counteract that is you make them special suits. All right, these suits, I'm going to do a very beautiful drawing of them. These suits here, they have in the wrist parts, they have weights, really heavy weights. Now, oh yeah, there's one on the chest. of course. One problem. Weight does not equal mass. So theoretically, if we were to bring up these weights and we wanted them to maybe use, let's just say 20 pounds, right? These are each like 20 pounds each. So they're kind of working, right? The thing is, if we wanted them to, if we put 20-pound weights on them, they're a lot lighter because of the zero gravity, because the mass of something is relative to the gravity of the place. Like, for example, if we went on to Jupiter, because of how big it is, get crushed immediately. So, like, there's a problem finding the big enough weights for it that are compact enough. But, like, if you were to do that, muscle dilation is caused by them not being used, and since there's no gravity, they're not being used. And the gravity with your muscles, so we'll say, for example, this is your foot, right? You have the weight here. Without the weight, this foot does not have the weight. The gravity normally would be pushing down on this, working the muscles in here. These are the muscles, they'd be working, right? But then when the gravity is taken away, the muscles tend to shrivel up. And theoretically, if we attached weights with, the relative mass, or respective mass, it would consistently be pushing down on the muscles, kind of anchoring them, or even if they were just floating sideways, like kind of pulling the muscles in any way, shape, or form would theoretically continue working the muscles so that they could, the muscles be active and they wouldn't dilate. And I think that's kind of all I had on that. And they could build full suits out of it. They could maybe just make them wear like arm straps, or like while they work out, make the muscle do extra. Of course, there is a problem because I talked to my teacher about this, about food and stuff. I don't think that's that big of a problem because got little suckies, and maybe they could turn other things into food. We don't know. We're very early in space exploration. I've got more crazy things to talk about.